We have few days to jam. So all you need now is to look at the topics that you don't know, that you need a review on. Just drop it in the comment section and I will do just that. Because I am actually up here because of a student that requested from my comment section that she need a review on specific heat capacity. So that is why I'm here. If you are joining for the first time, please don't forget to subscribe to this channel and turn on notification because you have a lot to learn from this channel. With no further ado, let's get right into the video. How much joules of heat are given out when a piece of iron of mass 60 grams and specific heat capacity 460 joules per kilograms per Kelvin cools from 75 degrees Celsius to 35 degrees Celsius? We have the following options. Option A, 1000 joules. Option B, 1050 joules. Option C, 167 joules. And option D, 1104 joules. This question says how many joules of heat energy. That means you're looking for the quantity of what? Heat. Now that is what you're looking for. The first thing that will come to your mind is to state the parameters. Okay, now from this question, let us analyze the parameters. We are looking for the quantity of heat. That is what? H is what we are looking for. Piece of mass given as 60 grams. Now the mass is given as 60 grams. And we have specific heat capacity as 460 joules per kilograms per Kelvin. So the symbol is what? C is equals to 460 joules per kilograms per Kelvin. Okay. We have the temperature. We said that it cools from 75 degrees Celsius to 35 degrees Celsius. That means at 75 degrees Celsius, the temperature was very hot. That becomes my theta 2. Do you understand? Because the body was actually what? Cooling. So I would say that theta 2 is equals to 75 degrees Celsius and theta 1 is 35 degrees Celsius. Now before you can solve this question, there is something that will come to your mind. Look at the mass given in this question. It's given as grams, okay? But the specific heat capacity, look at the unit. It says joules per kilograms per Kelvin. Now you cannot solve with grams and also with kilograms at the same time. No, they must be of the same unit. So what are we going to do? We are going to convert this mass to kilogram simply by dividing by what? 1000. So let's go. My mass is equals to 60 over 1000. Now this cancels this. Is going to give me 0.06 kilogram. Is that clear? Now the next thing we are going to do is to state our what? Our formula. So what's the formula? The quantity of heat H given up from a body is equals to H is equals to MC what? Theta. Okay, I will say bracket theta 2 minus what? Theta 1. Now let's just put in the values. We have that H is equals to, my mass is given as what? 0.06 multiplied by, my C is given as what? 460 multiplied by, then my change in temperature is what? Bracket 75 minus what? 35. Okay, now what are we going to have? We have 27.6 multiplied by, the change in temperature is what? 75 minus 35. That gives us what? 40. So by the time we multiply this by 40, we have 1104 joules. Is that clear? So this particular one is quite simple. So the quantity of heat given up from a body H is equals to MC what? Theta. From what we've got so far, the correct option to this question is option D. Hot water of mass m kilograms at 75 degrees Celsius is added to 4 m kilogram at 25 degrees Celsius. The mixture temperature is what? Option A, 25 degrees Celsius. Option B, 35 degrees Celsius. Option C, 45 degrees Celsius. Option D, 55 degrees Celsius. Before we could solve this question, you need to understand the concept, which says that what? Energy lost from the hot body is being gained by what? By the cooler body. Do we understand? For example, to bathe a warm water whereas the water was cold. So what do you need to do is to add what? Some amount of what? Hot water. By the time you add that amount of hot water, the temperature of the cold water will do what? Will rise. While that of the hot water will do what? Will reduce. Do you understand? So it becomes a mixture of hot and what? Cold. That becomes a warm water. So that is what we are trying to explain. So let's bring it down. Now look at it now. Heat lost by hot water is equals to heat gained by cold water. Now, the only thing that is different in this question now is that the temperature difference. Now, the quantity of it given by an object, let me say this is M. M of what? Hot. C of what? Water. Then theta is temperature hot minus temperature what? 2. Is that clear? M cold. C water. Temperature 2 minus temperature what? 1. Now let me explain further by saying that using this beaker to explain, this is what? Hot water. This is what? Cold water. The temperature of this hot water is theta what? H. While the temperature of the cold water is theta 1, right? Now I want to bait a warm water because this particular water is what? Is very, very cold. What do I need to do? I'm going to add this hot water into this what? Cold water. And by the time I add it into this cold water, the temperature of this cold water will do what? Will rise, right? Now the hot water inside this cold water is going to do what? Reduce. Do you understand? The temperature of the hot inside this cold water is going to do what? Reduce. Now, which one is losing heat and which is gaining heat? Heat is being lost by the hot water and is now being gained by what? By the cold water. I don't know if you understand what I explained. Now, inside this cold water, they have a new temperature, which is what? Theta 2. Do you understand? That is a new temperature. Now, that new temperature, because the temperature of the mixture, because we have mixed the hot and the cold together. So if they ask to calculate the temperature of the mixture or the final temperature of the mixture, what you're looking for is the theta what? 2. Because at first, when you did not add the hot water, it was on its own. By the time you added it, the temperature of the cold water did what? Increase. While that of the hot water did what? Reduce. Do you understand? So, because that of the hot water reduced, it said to what? It's losing out what? Heat. Now, because what? The cold water is becoming warm, so it's gaining what? Heat. Do you now understand it now? So this theta 2 is the temperature of the mixture. That is what we're actually looking for in this particular question. I hope that is clear. So let's solve the question. Now this question says, hot water at mass m kilogram. That means the mass of the hot water is what? M. So I will say M hot, okay, is equals what? M, right? And its temperature is given as 75 degrees. So theta hot is 75 degrees Celsius, right? It's being added to 4m kilogram at 25 degrees Celsius. Now they might not tell you that this one is cold water or this one is hot water. They are going to use the temperature difference to know. The one that has the higher temperature is that of the hot. The one that has the lower temperature is that of the cold. I don't know if that is clear. Now the mass of the cold water, which is m what? C, is giving us 4m. Is that clear? And the temperature of the cold water, that becomes my theta 1. That means theta 1 is equals to 25 degrees Celsius. Is that clear? So what are we looking for? We're looking for the temperature of the mixture. Okay? Now you're looking for theta 2. Is that clear? Simply by saying heat lost by the hot water is equals to what? Heat gain by the cold water. Voila. And that's it. Now we're going to say that heat loss by hot water is equals to heat gain by cold water, right? Now the heat lost by hot water is equals to what? M hot C water bracket theta hot minus theta 2, right? Now this is equals to M cold C water bracket theta 2 minus theta 1. So because, look at the formula now. Now because this is the same, we are using specific heat capacity of water. So we are going to have M hot bracket theta H minus theta 2 is equals to MC bracket theta 2 minus theta 1, right? So what's my M hot? My M hot is what? M bracket, my theta hot is 75 minus what? Theta 2. Now is equals to M cold is 4M. My theta 2 is what I'm looking for, minus what? 25. When I work it, I'm going to have that M cancels what? M. So this is 75 minus theta 2 is equals to, let's multiply. What do we have? This is going to give me 4 theta 2 minus 100. Are we there? So collection of like terms. Then I'll take this to this side and take this to this side. So 75 plus 100 is equals to 4 theta 2 plus theta what? 2. This will give me 175 is equals to 5 theta what? 2. So my theta 2 is equals to 175 over what? 5. Then my answer becomes 35 degrees Celsius. Do you understand? So this is how we can solve this problem. Just set your parameters correctly and actually know that the temperature of the mixture is the temperature that is in common between the hot and the what? And the cold. Do you understand? So the correct option from what we've gotten so far is option B. A 500 watt heater is used to heat 0.6 kilogram of water from 25 degrees Celsius to 100 degrees Celsius in T1 second. If another 1000 watt heater is used to heat 0.2 kilogram of water from 10 degrees Celsius to 100 degrees Celsius in 22 seconds, find T1 divided by T2. Okay, we have the following options. Option A, 50. Option B, 5. Option C, 5 over 4. Option D, 1 over 4. This question says an electric heater. So you must know that if you're using a heater to heat up a solid or a liquid, the quantity of heat is no longer going to be the same with what we are using. Is that clear? So let me explain that. You know that the quantity of heat, H, heated on a particular body is equals to mc what? Theta, right? But if you're using a heater, an electric heater now, to heat up this water, it's not going to be H now. It's going to change. So this my quantity of heat, H. We now change to what? IVT or I square RT or V square over RT or PT. Do you understand? I have to write all these formulas for you in case anyone you see wants to hear quantity of heat heated gotten from a heater. A heater is no longer going to use H equals to mc theta. Okay, so you're going to use either of them depending on the parameters you have in that particular question. So if you have current and voltage with time, you're going to use what? IVT equals mc theta. So don't get it confused. Anytime you see a question that involves electric heater, don't use H, but use either of these depending on the parameters given. So let's get back to the question. The question says a 500 watts heater, that means that is the power, right? So P1 is equals to 500 watts. Is used to heat up 0.6 kilogram of water. So M1 is equals to 0.6 kg. 25 degrees Celsius to 100 degrees Celsius. So my theta 1 is 25 degrees Celsius. Theta 2 is 100 degrees Celsius. In T1 second, that means the time is what? T1, right? Now another heater that rated 1000 watts, that is P2. P2 is equals to 1000 watts. Is used to heat up 0.2 kilogram of water. So the mass of the second water is 0.2 kilogram, right? And the temperature ranges from 10 degrees Celsius to 100 degrees Celsius. So for this second one, theta 1 is 10 degrees Celsius. Theta 2 is 100 degrees Celsius. I said in T2 seconds, so that means my time is what? T2. Asked to find T1 over T2. So let's find them. Now for the first instance, I'm going to use what? PT is equals to MC what? Theta. Is that clear? Then for the first one, I have what? P1 T1 is equals what? M1 CW theta. So let's just put in what we have. What's my first power? I have 500 T1 is equals to, so my M1 is what? 0.6. The specific capacity of water is constant, so we can do away with it. Multiplied by the C of water is constant, you can just say CW, then times my theta here for the first one is 100 minus what? 25, which will give me 75. Is that clear? So this is, so my T1 is equals what? 0.6 times 75 CW divided by what? 500, right? So let's say what we have. So we have my T1 to be 0.09 seconds. Now, similarly, we are doing the same by applying what you have. So this one I have what? T2 is equal to, using the same method, I'm going to have what? 0.2, that is the mass, multiplied by the temperature change is what? 90 seawater, divided by the power, which is what? 1000. Then it's going to give me what? I have 0.018 seconds. Okay? Now the question says we should find T1 over what? T2. So my T1 is 0.09 divided by what? 0.018. So let's work it out. And my answer is equal to what? 5. Is that clear? Now mind you that the C of water is the same, so it can cancel out. Do you understand? So that's why I do not have effect on this answer. Do you understand? It's going to cancel each other. So the correct option to this question is option B. The quantity of heat energy required to melt completely 1 kg of ice at 30 degrees Celsius is what? And we are given the latent heat of fusion equals 3.5 times 10 to the power of 5 kilograms. Specific heat capacity of ice equals 2.1 times 10 to the power of 3 joules per kilograms per Kelvin. Now we have the following options. Option A, 4.13 times 10 to the power of 6 joules. Option B, 4.13 times 10 to the power of 5 joules. Option C, 3.36 times 10 to the power of 4 joules. Option D, 3.56 times 10 to the power of 2 joules. Now before I could solve this question, I need to explain it with a diagram. There's something you must know. Now there's what we call latent heat. Latent heat is a hidden heat that causes a change of state without a change in the temperature. Okay, so we're going to apply it here. Ice in its solid state has a temperature of 0 degrees Celsius. Okay, temperature of pure melting ice is 0 degrees Celsius. So this is what? 0 degrees Celsius. That is theta of ice is what? That is the final temperature of ice is 0 degrees Celsius, right? Bring out your soup from the freezer. Allow it to melt without heating it up. The soup is going to melt completely, right? Now it has changed from solid to what? Liquid state. But did you apply heat? No. Did the temperature increase? No. Do you understand? So that is a change of state. That is a latent heat that causes a change of state without a change in temperature. So this ice now, if you allow it after a while, it's going to change to what? Water. So when it changes to water at this stage where this is where we have latent heat of what? Fusion. When ice changes to what? To liquid without applying heat to it, becomes latent heat of fusion. Do you understand? So and the temperature of this liquid here is still what? 0. It's still the same temperature as that of the ice because we did not apply heat. So it will remain at this state until we apply heat before it can move what? It can move to the liquid state. Do you understand? So the ice in its solid state has mass, it has specific heat capacity, and it has what? Temperature. So at this particular point, you have what? Mass of ice, specific heat capacity, and what? And temperature. That is here. Okay? But at this point, the ice has changed to liquid, but without a change in temperature. So the same temperature the ice is bearing here, that is where the liquid is still bearing here. So that same temperature that the ice has here when it was in solid form is still the same thing it has when it is in liquid form. So that is latent heat of fusion. Okay, so that is why we call it MLF. There is no change in what? In temperature. It's still the same as 0 degrees Celsius. Do you understand? So now the liquid in its state, when you apply heat to the liquid, it's going to do what? Heat up. So this becomes M water CW theta what? Let me just say theta. Okay, now by the time you heat up this water to rise up to 100 degrees Celsius, which is the boiling point of water, is going to turn into what? Vapor. That becomes what? Latent heat of vaporization. That is, it is the same temperature of the boiling point that the water tends to do what? Vaporize. Okay, so we have this. This is latent heat of what? Vaporization. At this point, the same temperature as the boiling point of water. So the temperature here is what? The same as 100 degree what? Celsius. Do you understand? So a solid can change from this state to this state to this state and to this state. If a question says, calculate the quantity of heat required to change this substance from solid to what? Liquid without a change in temperature. That means you are considering the quantity of heat here plus the quantity of heat here. Do you understand me? But if the question says the quantity of heat required to change it from solid to what? To liquid at a higher temperature that is not zero, that means you're going to calculate the quantity of heat here plus the quantity of heat here plus the quantity of heat here. And what if they include vapor? You're going to include the quantity of heat here plus the one here plus the one here plus the one here. That is only we can get to what? Vapor. Do you understand? But that does not mean that we will not have initial temperature of ice. Ice can be as minus. Like the one given in this particular question, ice is what? Negative sign. So if ice is negative sign, that negative sign becomes the initial temperature of what? Ice. Okay? Because using a number system, this is what? 0 degrees Celsius, right? Now, if ice is given from this way, let me say minus 10. So this becomes minus 10 degrees Celsius, right? Now, at this point, this becomes the initial temperature of ice. That is what? Theta 1. This is ice or solid. Now, when you allow the substance to melt, it's still going to change to what? To what? To liquid at this same point. So this becomes what? Theta 2 of what? Ice. Do we understand? Now, by the time you apply what? Heat. And at this same point, you have latent heat of what? Fusion. Exactly. By the time you apply heat, what are you going to have? You're going to have what? It will change to what? Water. This becomes water. You have another new what? Temperature. Now this is water here. Okay? Now for the water, this becomes the final temperature of water, while 0 becomes the initial temperature of water. Because the object have changed, the substance has moved from liquid form, which is normal form, latent state of fusion, to what? Water, when the temperature has increased. Do you understand? So what actually happened in this change of state is the temperature difference. Temperature change from one form to what? Another. I hope that is clear. So let's go to the question. Now let's set our parameters from this question. We are given the mass to be 1 kilogram. We are given the initial temperature of ice to be minus 30 degrees Celsius. We are given the latent heat of fusion to be 3.5 times 10 to the power of 5 joules per kilogram, of ice to be 2.1 times 10 to the power of 3 joules per kilograms per Kelvin. Now we're looking for the quantity of heat. So this is what? The ice. This is water. But this is latent heat of what? Fusion. Okay? The quantity of heat here is equal to what? MC theta. Okay? This is what? C of ice. Now this substance is changing from solid state to what? Liquid state at the same temperature. And the temperature we're given is minus what? 30 degrees Celsius. So we are looking for the quantity of heat from here to here. So we're going to add them together by saying that this is ml what? F. And they did say to water at a higher temperature. You can see that this minus 30 degrees Celsius is still within the temperature of what? Ice. So let's go. And the quantity of heat you're looking for, H, is equals to MCI theta 2 minus theta 1 plus ml what? F. Is that clear? So let's solve the question. I have that my H is equals to, so what's my mass? My mass is 1 multiplied by 2.1 times 10 to the power of what? 3. Okay? Alright. Then bracket 0, which is what? The final temperature of ice, and is also constant, minus bracket minus 30. Right? Then plus 1 times the latent heat of what? Fusion, which is 3.5 times 10 to the power of what? 5. Is that clear? So we have that H is equals to, by the time you multiply this, you have this is 2.1 times 10 to the power of 3 times what? 0 minus minus is plus, so you multiply by 30. Okay? Plus this one, which is 3.5 times 10 to the power of what? 5. Is that clear? So let's work this out. What do we have? We have H is equals to, by the time you multiply, you're going to have 63000, right? Then I will now add it to us. This one is something I'm saying 350000. Is that clear? So you can now add them together to get the total quantity of heat. So it's going to give me 413,000, right? This is what? Joules. But the question left the answer in standard form. So we'll go this way. 1, 2, 3, 4, 5, right? So H is now equals to 4.13 times 10 to the power of what? 5 joules. Is that clear? So this is how to solve problem involving specific latent heat of fusion or even what? Vaporization. I hope that is clear. From what we've got so far, the correct option to this question is option B. I hope this video was able to help someone out there. Please don't forget to subscribe to this channel and turn on notifications to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for this same forthcoming exam can see it and learn from there. I'll see you next time in the next episode. Bye for now.